You're gonna be recording this video. So for those that are not watching this live, we've just barely started the lab video. This is on YouTube, so just go back through and watch the first minute, and just yeah, everything else from here you'll be able to see, you know, with the class. So. All right, we're all good? Writing this down? Cool.
Yeah.
And I do want to ask, does the video look smooth, or does it look kind of like uh, a laggy a little bit?
It's a little choppy, but it's not bad.
Okay. Everyone else think the same thing? Yeah, okay. Okay, I'm not sure if there's anything in your data sheet that you have to take from this part. No? Okay, so we can move on. So one thing I will say about this, I would recommend to not scoop it so far away from the beaker. I'd probably pick up the actual watt glass and kind of hold it next to the beaker, and then pour it in there as to not spill it, you know. So I'm sure some of you guys have cooked before, so it's kind of the same concept. record final volume. Okay, I'm guessing we'll get the final volume here in a second. Can anyone tell me why he's adding water to the ice bath?
Kind of makes it more cold, right?
I
Speeds
want
down
to
the heat.
To cool it evenly.
to cool it evenly, right? Because then if it's just ice cubes, then they're not all gonna make contact with the glass evenly. So having that water there kind of like equally distributes the contact on the beaker. So yeah, so do we know why we want to put it in the ice bath only when it's warm and just like not right away?
Impurities.
Impurities, right? Can you elaborate on that a little bit?
If it's cooled down too fast, it could get inclusions, carbons, oxygen, bubbles.
Okay. And who's talking? I'm sorry. Hello,
Sean.
Sean. Oh, hey, Sean. Would you be able to turn on your camera? It's one of the things I'm asking all the students to do it so that way you know you guys are all paying attention, all that good stuff.
Oxygen, bubbles.
Okay. All right. Cool. All right. Keep pressing forward. Can anyone tell me what this suction filtration setup is what it's used for?
It's to help with drying.
For drying. Anyone else? Okay. Yep. basically it, just to help with drying. Taking out all the liquid, it really like, gets all of it out. You don't really want to have any left behind, because then there's a chance that you might have some impurities in there. If it's still wet. So when you go to do your melting point, it might not be accurate. Okay. Okay, so did anyone have any questions about that video?
So are you going to give us some of the problems for the data sheet that we're still missing? Some of the information?
All the data should have been provided in the video. At least that is how I understand it.
So wait, I didn't see final volume of solution, and I didn't see how long it told us it was allowed to stand at room temperature. All I saw was the ice bath.
It was for 20 minutes.
Oh, it was it?
Yeah.
Okay.
Sorry.
Sorry about that. I didn't see that.
No, it's okay. And it wasn't actually like in the video. He said it very softly during the video.
Oh, okay. And so did he give us the final volume of solution?
Let's go back through. I believe your original starting volume was 15 mil, no?
Correct.
Right.
And then
so,
he added some.
Yeah, he added some a little bit, right?
Mm-hmm.
I would say roughly 20 mils.
Okay. And that is what I shall put.
Okay. So yeah, I think that was. Anyone have any other questions about the video? I'm gonna stop sharing my screen.
I also missed the mass of the crystals isolated. I don't know if you said that or.
So the original mass?
No,
How-
after drying.
Yeah.
Final mass.
I didn't. Yeah, there's no mass. He never weighs it. So I don't know how you're supposed to get that from that. I'm gonna check on that and then get back to you guys. But yeah, he never weighs it in here. So did he say if he's gonna post like a data sheet or something like a? Hey Sean, I can't hear you, and you're like breaking up real bad.
No.
Say that one more time, Sean.
Yeah, he never said he was gonna post anything at all.
Okay, yeah, I'm gonna ask him about that because clearly in the video, and I'm also watching this for the first time. I'm just like you guys are, so I never had a chance to kind of watch it and ask him about certain things. So I'll get with him and find that out. But yeah, I mean, you guys don't know what your percent recovery or is anything like that because there's nothing weighed out. So, so what I do want to do is I want to go through those questions with you, the in-class questions. Yeah, because these questions are your PostLab questions. So, all right. So for these questions, I'm probably just going to call on someone to answer. So be prepared for that. So for the first question, let me share my screen with you. So can we all see that?
Yeah, I definitely uploaded these as the pre-lab questions instead of the post-lab questions because I just opened my book and saw questions.
Yeah, so if you would have went further down, I think I put it in the chat too, but there's a page 35 here titled Pre-Lab Assignment. So, if you want, go back and, what's it called? Re-upload that. But yeah, so that's your pre-lab. So those other questions are your post-lab assignment.
All right. Yeah. I mean, I can see that now. I was.
Yeah. Yeah. So, but yeah, and just take that post-lab assignment that you put for the pre-lab, and then I submit that for your post-lab, so that way I have everything in the right place.
Okay.
And we have to answer these questions too as well.
Answer the.
Yeah, the question section.
So yeah, this is your post-lab. I know it's not titled post-lab questions, but this will be your post-lab.
Okay.
Yeah. So, sorry guys.
So what if I didn't upload them?
Upload
This as a post-lab. These are post-lab, not pre-lab, right?
Yeah, so this right here is post-lab. So that's not due until Monday.
Okay.
Yeah. So that's what I'm going to go through with you guys. Just kind of talk about, I mean, we're basically going to do them now. Maybe a couple of them I might want you guys to do on your own. But for the most part, we're going to, I'm trying to get through it now just so that way kind of all on the same page and to also prevent a lot of questions over the weekend. So at least we can get talking about it and stuff like that. So anyway, so for the first question, why might the melting point of the crystals obtained in this experiment be close to but below one of the reference melting points and melt slowly over several degrees? Let's see. Christina Alvarado.
I think maybe because it's not the purest form of the compound the melting point is being compared to.
Okay, so what might an impurity be? Like what might be, and don't think of it just being like an impure compound, but just like what can cause it to not melt within its what's it called, appropriate range.
I'm not sure.
All right, so we're talking about it. Trey, you got an answer for me?
I don't know. I think you might be getting at like vapor pressure, just like from the. I mean, it's an open container though, so I don't know.
Yeah. So don't. It's not anything like, I'm not trying to trick you. So, what was your crystal in?
Water.
Okay. So why might it not melt within its reference range? It might still be wet, right?
Okay.
Yeah, it's it.
That's
yeah,
a
nothing.
much simpler answer than
Yeah, nothing about vapor pressure or anything like that. But I mean, maybe some more advanced stuff. That's a factor, but not for 2130. So anyway, so would you expect the melting point of the recrystallized crystals to be higher than, lower than, or the same as the first crystals, and why? Sierra, is it Pfeiffer? Okay.
Yes.
All right.
I put that the melting point, I answered these as pre-lab, so I already have it. That the recrystallized crystals would be higher because recrystallization further purifies the substance, and so it would be higher.
Okay. Anyone else want to add to it or have a different answer? Okay, cool.
So it would be a higher melting point?
Be a higher melting point, right? Than the first crystals. So what about the first crystals makes it have a lower melting point? And then my next question is, and this isn't a question on here, but would it melt? So have you guys used a little melting tent machine before, where you take the capillary tube, put something in there, and then watch through the little magnifying glass and see it melt? No? Okay, so I don't know how to describe it without drawing it, but basically you have it in the capillary tube, and it'll kind of like start, like, imagine this is like a capillary tube. It'll kind of like, and it's full like that. It'll kind of like melt just slowly, so once it starts to melt here, like at the start, that's when you start the melt, right? So let's say it starts at 110 and it melts, and it gets to like 145. That's a pretty huge range. But you'd probably say that that's an impure compound, right? So if it was something that's pure, what I'm trying to say is that it would probably all melt at the same time. So or close to it. Start at like 110 and finish at like 112 to like 115. Have a very short, narrow range, because it's a homogeneous compound. It's not having to adjust its, how to say this, not having to account for different compounds as it's going through the capillary tube melting things, if that makes sense. And then for number 2, a reference book mentions that naphthalene can be recrystallized from ethyl alcohol. The student takes some crude naphthalene and dissolves it in 100 ml of boiling ethyl alcohol. After slowly cooling to room temperature and letting the solution sit for a long time, no crystals appeared. After slowly cooling to room temperature and letting the solution sit for a long time, no crystals still appeared. Letting a small amount of surface solvent evaporate, then swirling and scratching the flask with a glass rod did not initialize crystallization. List 2 other things that could be done to try to obtain crystals from this solution. And like he says, throwing out the solution, starting over is not an option. Does anyone have any ideas of, what you could do?
Add more naphthalene.
Add more naphthalene, okay.
That's what I put as well.
That's a good.
You can also reboil it and add more compound.
Reboil it and add more compound, okay.
Could you cool it in an ice bath?
Yeah, okay, okay. Those are all very, very good answers. And that's one question that I do want you to kind of think about more and answer that. If you're good with the answers that we have here, those are all very good answers. But if you guys want to take more of a closer look at the situation and answer it, this isn't due until Monday. Let's see where we got. Okay, cool. So from the following information on compounds A, B, and C, predict which solvent of the ones listed would be the best to use to crystallize pure A from a mixture of the 3 with the least contamination from compounds B and C. Explain why the solvent was picked. Assume that the solubilities of A, B, and C increase uniformly at higher temperatures. So we don't know anything about the compound, right? Just A, B, and C. So we don't know if it's polar or non-polar or anything like that. So it's asking us to predict which solvent would be the best to use to crystallize pure A from a mixture of the 3. So what do we know about as far as to recrystallize something? What do we know about what we want in terms of solubility of our compound? Like when do you want it to be soluble? When do you want it to not be soluble?
If we're isolating it, we want it to be the least soluble. So we would need the ethyl alcohol. The ethyl alcohol, okay. Do you want it to be soluble at a boiling point?
I mean, I think we would prefer that it be soluble at the boiling point and at least less soluble at room temperature than the others, yeah.
Right, right.
And cools, it crystallizes.
Exactly. That's exactly right. And that's kind of like why I wanted to ask is, you want it all to be soluble, right? To give it the chance to recrystallize, to purify, right? Good job. So yeah, so the answer for this one would be ethyl alcohol compared to chloroform. Can someone tell me, based on this data here, why we would not want to use chloroform? Someone not named Trey. Christine Arnold. Can you give me an answer?
Because it's like not soluble at all, pretty much, almost.
Right on. And also, can you talk a little bit about B and C?
So for B, it would be ethyl alcohol again, and then C.
So I'm not saying which one would be like what we use, but like why? What else other than A not being that soluble in chloroform well, we actually don't want it to be soluble, right? To be soluble in chloroform. So why is it that we don't pick chloroform? Because it is not soluble. So really, chloroform would be a better choice if not for B and C. Why is that?
I am not sure.
Anyone want to take a stab at it? Ashley, take a stab. Nothing. Trey, sure you have something for me.
Because compound B is less soluble and more likely to crystallize first. Or
Right. Exactly. And what do we not want from B and C? You can answer.
Crystallization.
Trey. Right. Exactly. Right. Exactly. Yeah. It's not a trick question. Anything like that. Okay. I'm going to speed through these last few. I do teach at 3. I teach another class, so I'm going to speed through these last ones. Suppose you want to recrystallize 10-gram sample of acetanilide from water. Answer the following questions. How much boiling water would be necessary to dissolve the 10 grams of acetanilide? This is just math. You guys can answer this one on your own. I'll let you guys do that one because that's just math. It's not a conceptual question. B also, how much acetanilide would be left behind if the filtrate, I think it's supposed to, in the filtrate, if crystallization and filtration were carried out at 0 degrees. And what would be the maximum expected % recovery of the acetanilide? And I believe that's with respect to doing this at 100 degrees. So the solubility will be 5.5 grams per 100 mils of water, and you're starting out with 10 grams. So yeah, so answer these last 3 on your own, just because they're more like a math intensive question. I can't really draw or anything like that for you guys. So anyway, does anybody have any questions about anything?
If we accidentally turned in those questions for the pre-lab assignment, are we going to get counted off for turning in the actual pre-lab assignment?
No, it's fine. I mean, I understand this is all kind of wonky. So what you can do is you can actually submit the pre-lab assignment to the pre-lab. I guess I'll have to extend it because I think it's already locked, so you guys can't get into there. So I'll do that, and then I guess I can send it to like tomorrow morning or something. I don't know, but and then for the post lab, for the questions you actually submitted for the pre-lab, submit those for the post lab. That'll be it.
Okay, thank you.
So and just real quick, guys, what do we think about this? Did you guys like actually watching the video as a class? He doesn't talk in his videos, so he